Assalamu alaikum. I hope all of you will be quite fine. For the today's lab session, the first command that we will be covering is the 3-point circle type. So as we had discussed in the previous lab session that there are 4 types of the circle command. First is the center end point, which is actually defined by the center, and the random point on the boundary, which actually defines its radius, because the distance between the center and the random point on the boundary is the radius. So we had also learned the dimensioning of its radius dimension and its diameter dimension with the help of dimension command and with the help of mouse in the previous lab session. So the other command was concentric circle, which we remember that its necessary requirement was that it must previously have either an arc drawn or a circle drawn. So this command cannot be randomly or independently drawn. Concentric circle command cannot be independently launched to create a circle. It must previously have defined an existing circle or arc. So this third type today is 3-point circle type. So this circle type is actually defined by randomly drawn or defined 3 points. So as here in the tooltip it says that create a circle by selecting 3 points. So those 3 points are randomly drawn on the screen, or they might be specified by the given coordinates, or they can be randomly picked from an existing geometry. So there are many ways to define those 3 points. For example, we can randomly or independently draw 3 points. For example, here in the sketching command we had learned in the previous lab session that this last column actually defines 3 construction type commands. For example, this is construction center line, this is construction point. So we can use this construction point and randomly draw 3 construction point anywhere on the screen. For example, here this is first point and this is the second point. This is randomly drawn, and third point can also be randomly, but it must be remembered that the third point cannot be located in the path of these previously drawn 2 points. Means the third point cannot be collinear with the previously drawn these 2 points, because in that case the circle will be undefined, because it will have an infinite radius of curvature, so which is impossible. So the third point, for example, it can be explained like this, that I can just draw a line connecting these randomly drawn 2 points. So here if I try to draw the third point, so here as we can see that it is actually showing the trace at this location. This third point is actually falling with the collinearity for the previously drawn 2 points. So this third point cannot be collinear, neither here, not on this line, anywhere. So it must be either away, on up or down, on either sides of this line. So here for example I have randomly drawn this third point. Now I can launch this 3-point circle command. So here I will be selecting this first point randomly. They can be selected in order or in any order. For example, first you can select this point, second you can select this point, and third time you can select this point. So it is quite random, you can select them in any order. So here this is the second point and this is the third point, and as we have observed that once the circle passes through the third point, it has been fully defined. Now we can, for example, delete this line segment. So 1, 2 and 3, these three points have been used to define this circle. So here we can also observe that this third point is actually defining the radius of curvature of the circle. So as much this point is non-collinear with the previously drawn two points, that circle will have a narrower radius of curvature, smaller radius of curvature, and its curvature will be greater, because if the radius of curvature is small, its curvature is lower. So if the third point, for example, if we try to make it to be collinear with the previously drawn 2 points, as we can observe here, so the circle size is increasing, so its curvature is decreasing and its radius of curvature is increasing. Radius of curvature is increasing as the third point goes collinear with the previously drawn 2 points. Its radius of curvature is increasing and curvature is decreasing, because curvature and radius of curvature are reciprocal of each other. So as we can observe here that the third point becomes as much non-collinear with the previously drawn 2 points. The circle has a narrower radius of curvature, smaller radius of curvature, and large curvature. So this is the first way of defining randomly drawn 3 points. So these 3 points can be defined by the given coordinates of 3 points by the geometry, or for example we can create a geometry that is actually containing 3 points. For example, I can create a random rectangle here, and as we can observe here, it has though it has many points, but it has 4 distinct points, these 4 corners. So any 3 corner points can be used randomly to define this 3 point circle type. For example, this point, and for example this second point and this third point. So the purpose is that the 3 points can be selected either from any existing geometry, or they can be randomly defined as previously have been drawn for this circle. So this was the 3 point circle command. The next important command is 3 tangent. So here, as we can observe here, the tooltip says that create a circle tangent to 3 entities. So entities means any objects that might be 3 arcs or combinations of arcs and circles. So here, as we can observe here at this stage, that this center end point, this type of circle can be independently drawn. This concentric circle type cannot be independently drawn, means it must have a previously defined arc or circle whose center should be existing prior to launching this concentric circle command. This 3 point circle can be independently drawn because we just have 3 points that can be randomly picked from any existing geometry, or they can be randomly defined. So this type can also be independently launched, and this 3 tangent circle type cannot be independently launched because it must have 3 tangent entities previously defined prior to creating this type of circle. So here are we can say there are 2 types, for example concentric and 3 tangent types from the types of the circle command, which cannot be independently drawn, and 2 types, center endpoint and 3 point, these 2 types of circles can be independently drawn. So concentric and 3 tangent types, these both types cannot be independently drawn because these 2 commands require a previously defined circle or combination of circles or arcs. Concentric point circle command must requires a circle whose center must be previously located. So these 2 types cannot be independently drawn, but center endpoint and 3 point circle can be independently drawn. So for quiz point of view, you must remember this fact. So as we can observe that 3 tangent entities must be there. So let us draw, for example I can draw a center endpoint type circle. So this is the first entity. So the other entity can be, for example a straight line can also be a tangent entity. For example this is the second entity, this is the first entity, this is the second entity, and the third entity can be a third line. Remember that third line cannot be collinear with this line, that can be at any angle, third line or third circle, or for example we can draw an arc randomly, for example here. So this is a random combination of one arc, one line and one circle. So these are 3 valid tangent entities. So now the 3 tangent circle command can be launched. So randomly draw, click on the boundary of this first circle and then click on this line, and here as we can observe here, important thing that while when we create 3 tangent type circle, so 3 tangent constraints are actually auto defined. So these constraints can be randomly removed and can be reassigned. For example I am removing this tangent. So as we can observe here that this circle, this line is no longer tangent with this circle. So if I want again that this line to be tangent on the boundary of this circle, so there are 2 ways. Either I can use this tangent constraint command. Here this is the tangent constraint, so I can simply click on this tangent constraint. So click on this line and click on this boundary. So this again tangent constraint has been defined. Another method of tangent constraint application is that with the help of mouse pad, or I will simply be selecting LMB this line and pressing control button from keyboard, and then clicking on this circle boundary, and in the side menu as I can observe that a tangent constraint has been listed. So in this way the tangent constraint or any constraint can be applied like this. So these other 2 tangent constraints can be removed and reapplied like this. So this is the 3 tangent type circle command which has been fully covered. So any 3 valid tangent entities, they can either be all 3 circles, combinations of circles and arcs, or three straight lines, but those all three lines cannot be collinear with each other, so they can be randomly at any angle. For example, as an again exercise, for example, this is the first line, so I can draw a second line at randomly at any angle here, and third line here, for example, at random angle. So again I can demonstrate this command here. This is the first entity, this is the second entity, and this is the third entity, and as we can observe here, this is the extended tangent. So I can drag here like this, so in this way. So any three tangent valid entities can be defined. They can be three arcs, combinations of arcs, circles and lines, etc. So this is the three tangent type of circle command which has been fully covered. The next important command is this arc command, and as we can observe here that arc has this many types: 3 point slash tangent end, center end ends, 3 tangent, and concentric arc and conic arc. Here 5 types have been listed here: 1 2 3 4 5. We will only be covering this first type, 3 point, center end ends type, and 3 tangent and concentric type. This conic type arc we will not be covering. So the first command here is 3 point slash tangent end, and as we can observe here its name, that 3 point and slash tangent end means this single command is used to create two types of arcs. This single command is used to create two types of arcs. One is type is the 3 point, and other type is tangent end. So let us first draw the 3 point arc. Remember, this 3 point arc is quite similar behavior like this 3 point circle, only here complete circle was drawn, and in this case only a portion of the circle arc is drawn. So the way of defining those 3 points are collinearity and non-collinearity of those 3 points, and control of curvature and radius of curvature is just like for this 3 point circle command. So this 3 point arc type can be drawn. For example, those 3 points can be randomly drawn here like this here, and as we can observe here, so the third point can be defined in any way. So randomly or 3 points can be any known points here can be drawn. For example, these construction point randomly and at any location. So click here this 3 point. So click on this first point, this second point, and this third point, and the arc has been defined. So this is the simple way of defining. And here, as we can observe, when 3 points have been randomly defined, so this is the coincident constraint, means point on entity is this constraint is defined. So this constraint actually means this point is coincident on this boundary. So if this constraint is removed, this point can be for example detached here like this. For example, if I remove this constraint, so this second point has also been detached. So again I am applying this constant. So this constant can be applied either here this quotient constant, so click on this point and click on this boundary, and other way is that, for example, click on this point and with the help of mouse press Ctrl the button from keyboard and click on the boundary of this circle here. So as we can observe here that this has been coincident on this circle. So this is the way of defining 3-point arc. So when 3 points have been defined previously, so a coincident constant is automatically applied. So this is the 3-point arc type. The next command, this is the slash and mean tangent end command. So if we want to create a tangent end command, so as the name indicates that an arc will be initiated from the tangent end of the existing entity or geometry. That tangent end can be of end of a line segment or end of any geometry, any existing geometry. So here the important point to be noted is that tangent end and R command cannot be independently used to draw an arc, because it must have an entity or object existing in the geometry which must have an end at which this tangent end R can be initiated or launched. For example, I can simply draw a line segment here. So as I can observe here, it's two ends, this end and this end are both are valid tangent ends for this tangent end R command. So tangent end R command will be launched and initiated using any end of this line segment. Or for example, I can draw an arc using 3 points. For example, this is the first point, this is the second point, for example. So here any these two ends, either ends of this arc can also be used as the tangent end for this tangent end arc. So for example, let us use this end of this line segment for the creation of tangent end arc. So as the way is that I will be clicking on this end of the line segment, which is the tangent end. So here I have just clicked here, simply LMB, left mouse button clicked, and here we can observe that as soon as we select the tangent end, so this was the tangent end. So as the tangent end has been selected, and a circle symbol which is actually divided into 4 quadrants. Here we can closely observe here that here are actually 4 quadrants. 2 quadrants are up and down, and 2 quadrants are front and the back end of the existing tangent end. Here this is the quadrant at the front end of the tangent end, and this quadrant here, this is on the back end of the tangent end, and this quadrant is on the upper side of this tangent end, and this quadrant is on the lower side. So here we have the option, because this is the common command for the creation of 3 point and tangent end. So when we have launched this command for the creation of tangent end, so we have to define or tell the system that my requirement is for the next command to create either the tangent end or a 3 point arc. So if we want the arc to be created as the 3 point, so we will be moving the cursor outside from this upper quadrant or this lower quadrant, means on the quadrants which are on either sides of the tangent end, this quadrant or this quadrant. I will be moving the cursor out of this upper quadrant or this lower quadrant, then 3 point arc will be initiated. But if I move the cursor here from this tangent end, first I have defined this tangent end, first I have clicked it, and after that if I am moving the cursor out of this front quadrant of this circle or this back quadrant of this circle symbol, then tangent and arc will be initiated. So here, as we can observe here, that I have clicked here, and when I have finished here, this is the tangent symbol appearing. So that means this arc is actually tangent at the end of this line segment. So this is the tangent and arc. So for example, I am creating the next arc, which is actually 3 point arc. Here I can observe here, for example, same command I have clicked here for the tangent end to be the end of this arc, this existing arc, this is the tangent end. Here I have clicked here, and here I can observe here, this is the front quadrant, this is the back quadrant, and these two quadrants, this quadrant and this quadrant are on either side of this arc. So if I am moving the cursor on out from this quadrant or out from this quadrant, so 3 point arc will be drawn here. For example, I can click here, so first point was already defined, and second point was this, and the third point is I am now defining. So this is the 3 point arc, means the same arc, same command is used to define two types of arc, tangent and end and 3 point end. But 3 point can be randomly or independently drawn, but after that the tangent and arc can be initiated once a geometry has been previously defined. So this is the tangent and arc. So another tangent arc and arc, for example, I can create here at the end of this existing arc. So the any end of this existing arc can be used as the tangent end. So for example, I have selected this end. So if I am moving the cursor from this quadrant out or from this quadrant, means this front end quadrant and this back end quadrant of this arc, a tangent and arc will be done. But if I am moving the cursor out from this quadrant or from this quadrant, which are on either side of the front and back end of this arc, so the 3 point arc will be drawn here from this quadrant. So this is the tangent and arc here, and this is the tangent constant, which can be reassigned and removed like this. For example, if I want to create this tangent and arc to be 3 point arc, so I can remove this point. So now, as we can observe here, that this arc is no longer tangent end, so it is actually transformed into 3 point arc. So this is the way that we can, if I want again to transform this arc to be tangent end, so I can click here, this is tangent constant, and I can click here and like this. So this is the tangent end arc has been defined. The next type of arc is center and ends, and it is quite similar like this center and point type, circle type. For example, here it says that center and ends means first of all will be defining the center of the arc, which will actually be the center of the corresponding circle. So after that the two end point which will actually be defining the limit or the angle of the arc that will be subtending at its center. So let us try this command. So center and ends means, for example, this is a randomly chosen center, and here for example this is the start point of the arc and this is the end point of the arc. So this is actually, these 2 points are defining the limit of the arc and are the angle subtending at the center between these 2 radii. So this is similar to center and point type circle, only the difference is there that in the center and point type circle complete circle is drawn, but here in this case only an arc is drawn in this type. So the next type is actually 3 tangent, and it is quite similar to this circle, this 4th type, the 3 tangent circle type. So the behavior of 3 tangent arc is quite similar to this 3 tangent circle type, means the requirement for this 3 tangent arc is also that it cannot be used randomly to draw independent arc. It is always used to create an arc using 3 existing tangent entities. Those 3 tangent entities can be any combination of arcs, lines or circles. So for example, as I have already an arc, I can draw a random line at any angle. So this is the second tangent entity, so I can draw a third entity. For example, I can draw a center and point type circle at anywhere at any random location. So here I now draw this 3 tangent arc. So here I am clicking on the boundary of this circle, and here in this and on this circle, here again click on this so actually the orientation of the existing tangent entities may have to be a bit realigned. We can try here. The system is actually doing non-responsive. The system had gone non-responsive. We were actually trying this 3 tangent type of arc. So any random 3 tangent entities can be drawn here. For example, this line segment, and I can draw, for example, here a circle, or randomly, for example, 3 point arc here like this. That can be located in any orientation. So here now, for example, I am drawing this 3 tangent type arc here like this. Click on anywhere on the boundary of the circle, and here in this like this. So this is the 3 tangent type arc, and as we can observe, its name indicates that there are 3 tangent constant applied when tangent type of arc is drawn. So as long as these tangent constants remain, this arc will remain tangent to these 3 entities, this line, this circle, and this arc. If I can, for example, remove this tangent entity, as now can I observe that this arc is no longer tangent to this entity or this line segment. So if I want again to make this line to be tangent at this arc, so the way is either that click on this tangent constant and click on the boundary of the circle and on this line, so this has become again tangent. Another way, as I had previously also explained, that click on this circle, this entity and the other entity, and here in the side menu this tangent entity constant has been listed, so it has been applied. So like this, these constants can be controlled. So actually this tangent arc command can be used similar to this 3 tangent type of circle. The next type is the concentric arc. So this type of arc is quite similar to this concentric type of circle command. So as we had previously observed that like this circle, concentric circle cannot be independently drawn. So similarly this concentric arc cannot also be drawn independently. So it must have a requirement that previously a circle or an arc must be existing. So here, as we can observe here, the circle is existing, this these 2 arcs are existing. So any of them is valid for launching this concentric type of arc. So click on here, for example, click on the boundary of this circle here like this. So here this arc has been completed and it will remain continued as long as you press MB button from mouse to finish this command. So in this way, for example, here again concentric circle type, for example, I want to create an arc which is concentric with the center of this arc. So we will be clicking on the boundary of this arc here like this, and after that and randomly drawn here. And the important point for this is that as the concentric type of arc, concentric constant is actually applied here. So as we can observe here, this is actually the coincident constant, this constant. So here I can, for example, remove this constant, so this arc is no longer concentric with this. And if I want again that this arc is to be concentric with this arc, so I can apply here, for example, like this. This is the center for this arc, and this is the center for this arc here. So I can observe here that these 2 arcs have again become concentric. So in this way you can make either concentric or non-concentric when concentric arc type is applied. Hence this type has also been covered. And the last one is conic arc, that you can leave for the time being. So only these 4 types of arcs which you will be covering for this lab session. And remember that 3 point is actually can be independently drawn. Center center and ends type can be independently drawn. This is the second time which can be independently drawn. And other three types, for example tangent and three tangent and concentric type. These three types of arcs cannot be independently used to draw an arc. These actually require an existing arc or existing geometry for creation of the arc. So remember this point, that 3 point and center and ends are type of arc can be independently drawn, but tangent and three tangent and concentric type, these three types of arc cannot be independently drawn. So all types of constants and application and reapplication, removing and reassigning of the constant for these types have been fully defined. Next command is the ellipse. Ellipse has two types: axis ends ellipse and center and axis ellipse. So axis ends ellipse, as the name indicates, and it is clear from the icon of this command that ellipse is defined by using the ends of an axis. As we are familiar that an ellipse has actually its two axes, one is major axis and other is the minor axis. So we will first be defining first axis. For example, I am demonstrating here. So axis and ellipse. So here, for example, this is the end of the first axis. So here this is the second end, and as we can observe here that defining of the third point will actually be justifying that the first axis, this axis was either major axis or minor axis. So if the third point has more distance from the this axis, so first axis will become the major axis and minor axis, and the second axis will become the major axis. First will become minor axis and the second one will become major axis. Actually, the center of the ellipse is auto-defined when the ends of the axis have been defined. Means this end and this end, when these two ends have been defined, the center of this ellipse has been auto-defined, and the if the half length of the third axis, means this axis is actually greater than the half length of this axis, then this second axis becomes the major axis and the first one becomes the minor axis. And here once again, for example, I can just randomly draw a simple line chain segment here like this. So here, as we can observe here, this is for example, I can define the length of this line. For example, say it will be 15. So here, as we can observe here, that this, for example, this line is to be one of the axes of the ellipse. So its center point will be at 7.5 automatically. So at 7.5 the center of the ellipse will be defined, and after that the distance between the center of this line and the third point, if the distance between the center of this line and the third point is greater than half the length of this line, then this line will become minor axis and other axis will become, which will be perpendicular automatically, will become major axis. And if the distance between the center of this line and that third point is less than the half distance of this line, then the second axis will become minor axis and this line will become the major axis. Let us exhibit it, demonstrate it. Ellipse, axis and ellipse. So this is, for example, the first end of the axis, this is the second end, and here, as we can observe, this has become the center. And if the third point here, as we can observe here, third point is here, as we can obviously observe that the distance between this center and this third point is actually greater than half of the length of this line, this point and this point. So this, the second is the major axis, this is the major axis, and this has become the minor axis, like this. For example, once again, this is the axis of the ellipse. So here, as we can observe here, the distance between the center of this line segment and the third point is actually less than the half the length of this line segment. So the second is actually the minor axis and the first is the major axis. So in this way, the ellipse is actually defined. The next type is center and axis ellipse, and it has just its different application, but the way of defining is similar. That in the case of axis and ellipse, first the ends of the axis are first axis are defined. Means actually while we are defining the launching axis and ellipse, axes are first defined, ends of the axis are first defined, means this end or this end. But when center and axis ellipse is launched, first of all the center of the ellipse is actually initiated. So here it can be created that here this is the center of the ellipse. So for example, this is the end of the first axis. So automatically, because center of the ellipse is actually at the center of the axis, so if the distance between the center of the ellipse and the third point is greater than the center of the ellipse and the first end of the axis, then the second axis will be major axis and the first one will be minor axis. And if this distance is smaller than the center and the first end of the axis, then this will become the minor axis and the first drawn will be the major axis. So this is a simple way. The only difference is that in the case of axis and ellipse, first of all the ends of the axis are defined and the center is auto defined. But in the case of the center and axis ellipse type, first of all the center of the ellipse is defined and the ends of the axis are auto defined. So we must remember this clear and concise difference, that in the axis ends types of ellipse, first of all define the ends of the axis and the center is auto defined. Ends of the axis are randomly defined or can be user defined, but its center will be the midpoint of those 2 points. And in the case of center and axis ellipse type, the center of the ellipse is actually defined by the user and the ends of the axis are auto defined when we create select the one end of the axis, the other end of axis is at the same distance from the center of the ellipse. So The other way of defining major and minor axis has been previously explained. The next type is spline type. Spline, as we are familiar that it is a curve which has a random curvature at various points. For example, we can define this ellipse, as we can observe here that we have selected random points on this screen, and this ellipse has been defined. And remember these 2 points which it has stated interpolation point. These are actually the control points for this spline, and by controlling these points, I am controlling these points by using LMB, and by pressing LMB and dragging the mouse. So in this way you can actually press LMB, left mouse button, left click from the mouse, and then you can simply drag the cursor, so like this. So in this way its curvature or radius of curvature can be randomly controlled. So these are actually the control points for controlling the concavity of this spline. So it is a random curve. It is a quite useful command. It can be used to create random trajectories and for creating paths, sweep paths for sweep command, while we will be covering 3D features. Next important type is the types of fillets. As we can observe here, fillet has mainly 4 types, but we will only be covering first 2 types. One is the circular fillet and other is the circular trim fillet. One is the circular fillet and circular trim fillet. And the very minute difference of defining between these 2 types is that in the case of circular fillet, we can observe here from the icon that this here we can if we read this tooltip, that this states that connect 2 entities with an arc. Construction lines are added that extend to the intersection point. Means actually to demonstrate this command, for example, I can draw randomly 2 line segments. They can be drawn at any angle, but I have drawn them orthogonally at 90 degrees. Here let us apply this command, circular type of fillet. Here, as we can observe that we have just selected these 2 line segments, and this circular fillet type has been created. And here, as we can observe that this was the original vertex. So the difference are the point to be noted in the type of circular type of fillet. Circular type of fillet, this trace which is actually showing the original vertex of these 2 line segments is actually existing. This trace from the original vertex to the start of this fillet arc, this is actually existing. But while we will be using this circular trim fillet, this trim will be not existing. This will be removed. So what is the application or advantage of this trace? That, for example, if we want this point to be reference it for another geometry. For example, we can create a center end point type of circle. So this point is actually available for referencing with the other geometries or connecting with the other geometries. But in the case of, for example, this other type, that is circular trim, as the name indicates, in the circular trim type, this original traces of the fillet lines will not be actually existing. Actually, the length of these traces is equal to the radius of this fillet. So these are actually defining the radius of the fillet. So the radius of the fillet can also be defined like this. For example, another way I can draw a, for example, a corner rectangle here like this. Means the points for this fillet radius can be used to define an existing geometry. They can be extended from an existing geometry. So this is the way to define circular type of fillet. While in the case of circular trim fillet, for example, again we can draw these two line segments like this, and again if we use this circular trim type of fillet, here as we can observe that a similar type of fillet is created, but the original traces of the existing vertices are not existing. So this is the difference. And in the type of circular fillet or circular trim fillet, two tangent constants are actually applied automatically, because the tangent fillet is automatically tangent to the line which at which it is applied. The next command is the chamfer type. Chamfer has also same behavior similar to this fillet type. It has two types. One is called chamfer and other is called chamfer trim. In the chamfer type, the original traces of the original vertex of the lines are actually existing. And in the case of chamfer trim, the original traces of the original vertex are not existing. Here we can draw, for example, this pair is used to create chamfer, and other pair can be randomly drawn here, for example, to exhibit or demonstrate chamfer trim. So here we will be launching this chamfer type. So here we can observe here that these original traces of the lines are actually existing, but here in this case, if we apply this other type which is called the chamfer trim, these original types are actually vertices, these original traces have been removed. So what is the advantage of these traces? That they can be referenced for an other existing geometry, but here this reference is not available. This here are three references can be used. Means this line segment which is in construction mode, and third one is this point. So this point can be any reference point for any other existing geometry, it can be added. For example, I can say I have drawn this circle and I want this point to be located at this point. So here I can apply, for example, this coincident constant here like this, and as we can observe here, so here this type of chamfer has more controls, means the for example the chamfer distance or chamfer parameters can be defined by randomly. For example, I can dimension this distance. For example, this is 5 units, so this is the first chamfer distance here, and similarly the other chamfer distance can also be defined like this. For example, I can say it to be equal, or this is also 5. So it has more controls, means chamfer distances can be auto defined. Here in this case those controls are actually not available, but its chamfer distance can be defined in other ways. So it has its own way of defining the distance of the chamfer. For example, we can click on this point, randomly select this point, and again this point here, and we can observe here that, for example, this vertical dimension can be defined like this with help of mouse. Here I can define it to be 5, and in a similar manner, for example, I can click on this point and click on this point, and here I can say this is the horizontal distance, this is 5. So in this way dimensioning can also be controlled. So the main difference between the chamfer and chamfer trim type is, in the trim type these traces are original traces are actually vanishing or disappeared. These are not existing, these are not available. But in the simple chamfer type, the original traces of the original knife segments are available. Next very important type is the text command, and as we can observe here in the tooltip, it says create text as a part of a sketch. So here the text is actually can be extruded, or it can be cut out from, means this text can be converted into 3D features, solid features. So this is not a simple text. This text can be actually extruded, or it can be cut out from the geometry. So how it actually works, so click on this text command, and as you can observe here in the status bar, it says select start point of line to determine the text height and orientation. So here this is, for example, the start point of the text. So the we can define any random 2 points that can be at any angle. Here in the vertical orientation, for example, if the second point is defined vertically, means the text will be placed horizontally here like this. So this will be actually defining the text height or letter height. So here now we can type any text of our own. For example, I can type it here gear, for example. So here I can observe here that this text has been placed. So this is actually the text height, which can be controlled by double clicking here, and I can define it to be, for example, 5. Its length is its height is 5 units. Here as we can observe here that the vertical constant has been applied. If I have, for example, deleted this vertical constant here, I can drag and press and drag, and can place it at any random angle. And if I want again that this text is to be placed horizontal, then I can use here, for example, this vertical constant, and I can make this line to be vertical, so this text has been placed horizontal. Other control is that this is actually the main controlling point for this text. Here this can be LMB, means left mouse button press and drag, and from this we can randomly or manually control the height, letter height of this text in this way. And this point is actually defining the location. If we are pressing LMB and at this upper point, and this point is actually defining the letter height in this way. These are actually the main controls for typing, creating any type of text. Another important thing is that sometimes we are required that this text is to be placed along some curve. So I can, for example, create a random arc, for example here. I can create a 3-point arc here like this, for example. I have created this random arc, but important thing is that this arc I have drawn it in the geometry mode, but for the text command this arc is actually recommended that this arc is to be drawn in the construction mode. Means for example, I am clicking on here and this is the construction mode, means this is not the main geometry, this is actually just a reference geometry. So this arc has been transformed into construction mode, because if it were in the solid or geometry mode, this text cannot be extruded or changed into 3D features. But if it is in the construction mode, this text can be converted into 3D features, or can be extruded or can be cut out. So click on again, I can click here, double click here on this text, and I can check this box place along curve. I can just check it here, and without closing this dialog box, I can go here in the background and click on this arc here like this. So this text will be oriented along this arc like this, and after that I can close this dialog. And the other controls are quite similar here like this, that we can create its height, like this. Arc length can be also created, can be changed, and gear or letter extent can be changed like this. So these are actually the main control for text command. Next important command is actually the offset command, which is very important, that you will be paying concentration. As the name indicates, offset command is actually used to create offset that can be offset any geometry. For example, offset has actually three types. Here if we click on it here, as we can observe here, the offset has 3 types. Select offset as single, chain and loop. So offset type command has 3 types. One is the single offset, other is the chain offset, and third one is the loop offset. So let us demonstrate these all 3 types turn by turn. First is the single type. In the single type, as the name indicates, you will be requiring only a single line segment that can be offset, and remember that can be single entity, means single object that can be selected by the single click. That can be a single line segment, that can also be a single arc segment. For example, we can try it here. Let us draw a line segment here. This is the line segment. I can draw it here, for example, for first of all, apply on this. So I have selected this offset type. This is the single type. So what is the method that I will simply be clicking on this line segment which I have to offset. So I have clicked it here like this. So after that we will be observing that a random arrow is shown here on any random side. So this arrow symbol will be shown randomly here on. We will be creating if we are inputting some positive number here, for example any number. For example, I can say I want to offset it 2 units, so I will be typing it here 2 units. So if this number is positive, the offset will be placed in the direction of this arrow, means on this side. And if I am inputting the negative prior to this digit or number, then the offset will be placed on the other side of this arrow. The arrow is on this side and the offset, this line will be offset on in this direction. So I can click here, I am tick marking or accepting this value, and as we can observe that the offset has been placed on the other side of the arrow. Arrow was existing on this side. So this is the single type of offset command. Once again, for example, I can again click on this type here. For example, I want to offset in the positive direction, mean in the direction of this arrow. So I can type it here, for example 3 units. So I am accepting this value like this. So the important point to be noted in the when we have applied single type of offset on the line segment, what type of constraints are actually defined. One is the parallel constraint, which is actually automatically applied on the single offset type when it is applied on the line segments necessarily. One is the parallel offset, because all line segments are parallel to each other, so a parallel one set has been applied. And the other constant, this constant is the equal length constant, because all 3 line segments are as many number times the offset is applied, all lines will be of equal length. So 2 types of constraints are actually applied when offset equal offset when a single offset type is actually applied. One is the parallel constraint set and other is the equal constraint set. So for example, these are all 3 lines parallel to each other and are of equal length of each other. For example, I want this line segment to be of unequal length, so I can drag it here. So as we can observe here that these 3 line segments are parallel to each other, but this line segment is of different length. as compared to, but these two line segments, because the equal constant is still there, so if I drag this lines, these two lines are actually constant with each other and they will have equal length as long as this constant is actually existing. As soon as this constant, for example, I am removing this constant, so this line length can be independently controlled. But parallel constant, as we can observe here, that it is yet applied, so all these three lines will remain parallel with each other. But if I want, for example, this line to be non-parallel, I can simply click on this, I can remove this parallel constant and this line is no longer remain is parallel. Again, if I want this line to be parallel with this line, I can click here simply, and after that I can press control button from keyboard, and here you can observe that this is the parallel constant, so this line has again become parallel. Again, if we want these three lines to be equal with each other, the way is that I can either apply this equal constant like this, and again like this, so these three lines have become equal with each other. So when single offset is applied on the line segment, parallel constant is applied and equal constant is applied automatically. So you must memorize this fact that when single offset is applied on a single line segment, then parallel constant is applied and equal constant is applied. Let us now draw, for example, an arc, single arc, and apply offset on this. So as we can observe here, I have selected the single type, so in the offset will be placed in the direction of this arrow. For example, I have typed it here 1 positive, so I have accepted the value. So as it has been observed that this arc has been offset 1 unit outside in the direction of this arrow. And if, for example, once again I am selecting this arc and I want it to be offset inwards, so I can, for example, type it here -4, for example, and I can accept this value. So as I can observe that this arc has been offset inwards 4 units. So this is the way of single type of offset in both the cases. And here in this case we observe that coincident or concentric constant. This is the concentric arc, just like this type of arc, concentric arc was actually drawn. So this concentric constant, which is actually the coincident constant, this is actually applied, and coincident constant has been applied 2 times because this first arc was actually existing. So when this arc was offset, 1 concentric constant was applied. When this arc was offset, then the second coincident constant was actually applied. So for example, I can delete this concentric, so I can, as I can observe, this arc is no longer is concentric with this arc, but this arc is still concentric because its constant is actually existing. If I again want this arc to be concentric with this, I can randomly, for example, this is coincident constant here like this, and I can click here like this, so this has again become concentric. So in this way, single offset type has been fully explained. The next type of offset is the chain offset. Chain offset is very important, as the name indicates that chain means actually it is not a loop, means not end-to-end connected, but it is an open chain. It can be an open chain or cross chain can also be there. For example, chain can be created by any type of geometries like multiple line segments and connected with portions of arcs, but they are not creating a loop. For example, here, I am creating this is these are two line segments. These are two line segments. So this is a chain. Means in the chain there are more than one segment. More than one segment must be there in the case of chain, but they should not create a loop. So I am launching this chain type of offset on the line segments. So the method is that actually in the case of chain type of offset, we will be selecting the end segments of the chain. But here, as we can observe, that there are only two segments. So these are actually the end segments. So I can click here, and this is the second end segment. So if I want to offset in the direction of the arrow, I can, for example, type it here positive. So here, as I can observe here, that inwards offset has been placed, chain offset. Here in this case, if we observe the types of constant, equal length constant is actually not available here, because the offset is placed perpendicularly at each and every segment, and only parallel constant is existing. Equal constant is not existing when we apply the chain type of offset on the line segments. When chain offset is applied on the line segments, equal constant is not available, only parallel constant is actually available. So again, for example, I can draw a better chain. For example, 3 line segment randomly here, or more than 1 2 3 4 5 6 sorry 1 2 3 4 5. Here are 5 line segments, and I can apply the chain offset here. So we will be first selecting this chain offset, then we will only be selecting the end segments, mean this end segment and this end segments on the either sides of the chain, and the whole chain will be auto selected. Means this segment we don't require to be independently select these line segments which are inside the chain. Only the end segments of the chain are required to be selected, and all the internal segments will be auto selected. So click on this line segment and then click on this segment, and if we want to offset in the direction of the arrow, input a positive number, for example 1.5. So as we can observe here, that parallel constant has been applied on this as well, and no equal constant. The other constant which is notable in the case when chain offset is applied is the coincident constant, because the points, the line segments are actually connected end to end and placed offset perpendicularly. So two types of constraints which are existing in the chain type of offset are parallel constraints and other is the coincident type of constraint here, because these two types of points are coincident, means end to end connected. So this is the important application of chain command. The third type is the loop offset. As the name indicates, loop offset requires a closed loop which is end-to-end connected. For example, this corner rectangle, for example, it is automatically a closed figure which has a loop. Slanted rectangle, or for example any type I can randomly draw. For example, using line segments I can create a random loop here. So as you can observe that this is a random loop. So the advantage of this loop offset is that if we want to offset the whole loop either inside or outside, then we will first be selecting this loop offset type. Then like the chain offset type, which actually required the selection of the end segments of the chain, means two segments which existed on the ends of the chain. In the case of loop, just like single, in the case of single the requirement was only that only a single geometry must be existing at one time, but in the case of loop we will only be selecting a single segment of the loop and the whole loop will be offset. Means like this, I have selected this line segment, and when I will be, for example, if I want to offset in the direction of the arrow inside, so I will be, for example, inputting 1 unit, so I will be accepting this value, so the whole loop is offset inwards. So again, the types of constraint which have been applied as parallel constraint and other are coincident constraint on this loop as well. So on the chain and the loop offset, coincident and parallel constraint are applied, and in the case of single type of offset, if applied on the line segment, then equal and parallel constraint are applied. But if on a single type of offset is applied on the arc, then concentric type of arc, concentric constraint is actually applied. Concentric type of constraint is applied. So this is the full coverage of the offset type of command. Next important command is the palette command, which is actually we can say the last command in this sketching module, because this last column, center line, point and body system are three construction types of commands which are actually auxiliary command, which are actually not independently used. So these will be used with other commands while we will be applying these editing commands, like this mirror command, for example, and this symmetric constant. So this construction center line will be used for two types of commands in the editing area for the this mirror command, and in the constraint area for this symmetric constraint command. And this construction point, which has been previously used many times, and this construction coordinate system will be used later. So the next important command in the sketching, which is the last, which is the palette command. And the palette are actually, if you can observe here, when we click on it here, sketcher palette dialog box is launched, and in the palette there are built-in complex figures which cannot be easily drawn using independent commands. So these are actually built-in and we can modify them according to our need. For example, 3-sided triangle, 4-sided square, 5-sided pentagon, etc. Or we can observe here that like profile, C profile, I profile, because if we want to create them independently using line segments, we will be taking a lot of time and a lot of effort. So these are actually built-in ready-made figures. We can simply modify their dimensions or geometries to satisfy our own needs, like shapes here. This is arc, racetrack, cross, oval, racetrack, etc. These are different types of stars: 3 star, 4 star, 5 stars, etc. So for example, I am drawing for example 5-sided pentagon here. So the way is that we will simply be normally selecting, this is highlighting, this polygon pentagon has been selected, and after that we will be pressing MMB middle mouse LMB left mouse button, left click, and after that we will be dragging it here in this window. So this is one way, and once we have place it here in the window, so here import section dashboard has been shown. Import section tab has been added. So here we can observe here that if we want some translation, rotation, etc., here we can randomly control here. So this point is actually, center point is actually used if we want to randomly place it on our decided location. And here this is just like we edit pictures in the Microsoft Word. This is actually rotates randomly here, and here angle is shown. Here scaling factor means the dimension will be unit, means it will not be scaled here like this. So it is the true scale. So once we have finished it, so this pentagon has been fully defined, and as we can observe that the polygon pentagon has all sides of equal length, and the side of one length of one side is given. So all length here we can observe in this pentagon is actually defined with the help of this construction circle. So every polygon is defined with the help of some construction circle. So all vertices of this pentagon are actually passing or located on this boundary of this construction circle, and the main notable constants are, this is coincident constant which is applied on the vertices of the polygon, and the other polygon constant important is the equal constant. So coincident constant and equal constant have been applied, and because this side is horizontal, so due to this reason here the horizontal constant has also been applied. So this is the way to control this pentagon. So this is the application of the palette type of command. Further its application will be demonstrated when we will be applying this feature practically, creating models. So another, for example, in the case of shapes or stars, for example 5 star, I want to create a 5 star here like this. So other way can also be like this. We can just double click here and here, once again click here. So this can be placed like this. Here again we can always use scale factor to be unit and the tools again. So like this, and you can go here. Further this circle can further this star can create result of this construction circle like this, and many constants have been applied. So as we can observe here, if we wanted to draw this shape, this would be very laboring and time consuming and very difficult. So some built-in complex figures or sketches are available in the sketcher palette dialog box that we can use them for our facility to save time. So this is the application and demonstration of the palette command as well. Next important features are in the editing area, editing commands, and here important commands are, this important command is actually delete segment, which is also called trim. So actually it performs multiple tasks, means it also deletes the complete segments, and it also trims the segments where they are intersecting. And other is mirror, and this one is corner, and this is the divide, and this is the rotate and resize. So actually here are 6 commands listed, and among which we observe that this mirror command is yet unavailable, and this rotate and resize is also unavailable, because these commands are actually become active when the conditions for their application are available, they have been fulfilled. Means if there is some geometry existing which actually fulfill their conditions, so these commands then become active. So let us first demonstrate this delete segment command. So for example, we can draw random geometries here like this. So simply the task of the line segment is that, for example, this complete line segment, if we click on it here, this will simply be deleted like this. But here if I click on this line segment, because it is actually this line is crossing it here, so it will be trimmed it from here. So this is the trim option. Again, for example, this line segment, this is continuous line segment, but as this line segment and this line segment are actually intersecting it here, so if I click on it here, so this will be trimmed between these two line segments. So similarly here, this can also be trimmed like this. And here, as we can observe here, that this line segment is completely can also be trimmed or simply deleted here like this. And again, this line segment can also be simply clicked and deleted. So we have done that this delete segment command actually works if there is some intersection, so it actually trims, but if there is no intersection, it simply deletes. Here, as you can see, because here is actually the intersection and this point is common, so here, as you can observe, these are 3 continuous line segments, so they can simply be deleted here like this. So in this way, it's a multi-purpose command. It also deletes the geometries and it also intersects. So this was the demonstration of that. And other important command is the mirror feature. This is very, very important. So as we have observed that in the sketching area, this last column center line and point, and this center line, construction center line, this construction center line is actually used for this mirror command. So how it is used, that we will the necessary requirement for this mirror command is that we must have an existing geometry. For example, I can simply draw a corner rectangle or slanted rectangle, for example, at any random location here, slanted rectangle like this. And the other requirement is that there must be a center line, and important feature is that this center line, actually it is the requirement, logical requirement, this because this is the mirror line. This should not intersect the geometry to be mirrored. It must be some distance. It is not recommended, though it might work, but it is not recommended that it should not intersect or pass the geometry to be mirrored. So it must be outside, because it, and after that these requirements are fulfilled for this mirror command. So here the construction center line has also been drawn, and the geometry to be mirrored has also been drawn. So the next requirement, or when as we can observe, this command is still inactive. So we will be selecting these two geometry, this construction center line. So the requirement is, when we want to apply this mirror command, we will be selecting the construction center line, which is the mirror axis. This is the mirror axis. So as soon as it is clicked, now we will be clicking on the mirror command, and after that it will be saying select items. So we will be clicking on this geometry, on this mirror command, and then on this line, and it will be mirrored above. Once again, for the mirror command, actually we will first of all be selecting the geometry to be mirrored. First of all, we will be selecting the geometry to be mirrored. So now mirror command is active. Now we will be clicking on the mirror command, and then we will be clicking on the this construction center line, and this geometry will be mirrored about this. And as we can observe here, that an important constant which has been applied here is the, actually this constant, this is called the symmetric constant. So as I had previously told, that this center line is not independently used, but it is used with the help of two commands, this mirror command and this symmetric constant. So this symmetric constant, symmetry means these points are actually symmetric constants applied on the points. So mirror is actually a multiple times application of symmetry. So here if I drag this point, so as I can observe that it is actually symmetric about this center line. So if I remove this symmetric constant, these points are actually randomly controlled. So this point is no longer symmetric or mirrored about this center line. If I again want this point to be mirrored or symmetric about this center line, so I can simply click on this point, then I can click on this point, and after that we can click on this line, or we can simply use here the symmetric constant like this, that click on this line of symmetry, and then this point, and then this point, so it has become symmetric. So again, this is the symmetric constant, actually works like this. Again here like this. So if I click it here and click at here, so here where the intersection was there, so the other segments, other portions have been actually omitted and a vertex has been created. And similarly, if I wanted to create the vertex here, but to remove or omit these two segments, then I would have clicked it here like this line segment, this portion, and this other portions would have been omitted. So these are two applications. And again, for example, I can click here at this line segment, and here at this line segment here like this. So here a random corner has been created like this. For example, this line segment, because this line segment here like this. So a random corner has been generated here. So this is the application of the cornering feature. Next important command is the divide command. This is quite often useful. So divide command is actually, for example, this is a single line segment, continuous line segment, and here when divide command will be applied, then it will be divide it into two segments. Here this is a one segment and this is the other segment here like this. So for example, I can click it here, so it has transformed into three independent line segments which have been connected with each other. So actually the purpose of divide tool is to simply split the segments into multiple entities or objects. The application for this is that actually while we will be using the 3D features, this will be used to split the trajectories, to place various cross section, for example for the sweep or swept blend command. When we will be demonstrating them in the 3D mode, geometry mode, then this command will be very useful. So this is the application of the divide command. And this last command is actually the rotate and resize command in the editing area. And rotate and resize command is quite simple. It is also available, still unavailable, because it will be available when the geometry upon which it will be applied is to be selected first. So for example, we can select this geometry first, and as we can observe here that this command is now available. So rotate and resize simply works like this here, and here are control. This actually, this is the central corner for moving it linearly, and this is rotational movement. Here the angle is given here. So this is actually the application of rotate and resize command. So in this way, sketching and editing area complete commands have been demonstrated. These constants have already been defined because these are not independently used. So in this lab session, sketching, editing, and all constants commands have been explained till now. Last command is actually remaining the dimension command, which will be demonstrated in detail in the next lab session. Thank you everyone for being patient.